Yes. I hope everybody understood, right? Yes. So, see, if you are able to solve one question, means you should be able to understand each and every point in that theory also. Okay. Chalo, next question. Next question is, I think it should be simple. Last step alone. 1 second. So what I did in the last step. Okay, let me do it here. So look at this step. No, last step means you're asking last step, right? 1 second. Here, CH3COOH. Okay, I'm writing dissociation. Okay, plus H plus. So I'm writing dissociation constant Ka value. So it is simply equal to dissociation constant, right? Acetate ion. Product side, no? You see, this is salt. And there is also H plus. And there is acid left side. So this H plus is equal to Ka into acid by salt. Okay. So you can just substitute. Actually, substitution you have not understood. Okay. What you can do, acid by salt, right? Acid concentration, everything is given. This is our acid concentration. This is acid concentration. This is salt concentration. So just Ka value is given. Okay. Just a substitution. Next question. I think you can easily solve this now. Okay. So what you have to do? Basic buffer. So weak base plus its salt. Done. Same thing you can proceed. Now you can practice this question also. Same. Buffer solution, we have given formula, right? So H plus is equal to Ka into what I've got here, acid by salt. Yes, sir. Now what you can write, if you take negative logarithm, pH equal to pKa plus log salt by acid you get. And just applying logarithm both sides. So this will be reverse. Okay, because I have used plus. Negative logarithm you apply both sides. Log A into B. Log K is one term, acid by salt, this ratio is another term. Just substitute this because directly pH is given. If H is given, you try this. pH is given, use this equation. Okay. So very simple question, right? Got it? Next question. Okay. Now solubility. Solubility of CaF2 in this solution. What exactly is solubility? Solubility means, let me define solubility first. Okay. Solubility is what? Number of moles dissolved per 1 liter in 1 liter of solution. Moles dissolved per 1 liter. This is basically represented with molarity. How many moles present in 1 liter of solution? That is molarity. Okay, so molar solubility, they're asking in 0.1 molar sodium fluoride. You treat like equilibrium, because solubility basically, when there is solubility is done, any salt is taken in water, suppose. So it will ultimately reach equilibrium. That is why we are discussing here. Okay, CaF2, look at CaF2 here. CaF2, Ca plus 2 plus 2F minus. So what I've done, I've just written equation. For this, KSP is given. What is a KSP? Again, equilibrium constant. This is solid. Okay, this is solid. It is a salt, but this is aqueous. This is aqueous. So what I should do, I should just write an expression for equilibrium constant, which we already know. Ca plus 2 and concentration of F minus power 2. Okay, this is how we write equilibrium constant. Very simple. Now what I'll do, sodium fluoride concentration is given. Sodium fluoride concentration means fluoride concentration is directly given. So fluoride is how much? 0.1 molar. So what is solubility? They're asking. So what I can do is, let me take solubility is S, and this is given. How much it is? 0.1. So what I'll do is KSP value, I'll put this 5.3 into 10 power minus 11, and this I'm taking solubility S, F minus 0.1 whole square. So what is S? So very simple, right? Look at this. What I did, very simple step. If you know equilibrium constant, means how do we write expression? Then rest all are done. Only two steps. X equation, and don't forget the coefficients. Don't forget. It's substitution. So 5.3 into 10 power minus 11 by minus 2. So 10 power minus 9. Understood? Everybody. So this is just application. अच्छा KSP formula once. अच्छा KSP formula, I'll take one general expression. So let me take AB. AB is a solid. Okay. Solubility means a salt is soluble in a solution. Salt is soluble in a water or any other solute, any other solvent. Sorry. So that is called solubility. Look at this definition. How many moles dissolved in 1 liter of solution? Okay, solid dissolved in liquid. Okay, a liquid is solvent, solid is solute. So solid is solute, A plus. But all the solubilities, what we do in this particular chapter, we do in water. So that is why I'm writing aqueous solution. Okay, B minus aqueous. So what is KSP here? Very simple. Product of these ions. It is just equilibrium constant. A plus into B minus. Sir, in equilibrium constant, we write reactant also. But why are we not writing here? In equilibrium constant, we never write solids and we never write liquids. Sir, why? Why are we not writing solid? We should write this. Why are we not writing? Anybody knows the answer? Why are we not writing solid, this solid? No, it is just equilibrium constant. We are naming it as solubility product because it is, this expression will give a meaning, right? What is the meaning of this? A solid is kept in water. Okay, it is producing ions. Yes or no? So that is called solubility. How many moles are present in 1 liter? We are measuring per liter of solution. That is solubility. Okay, so A plus B minus into B. These are products, fine, but reactant is AB. We don't write this. Never write solids and pure liquids. Solids and pure liquids, their density doesn't change. Very important, no? Whatever the solid amount you use it consumes in the reaction, no doubt. Solid is consuming in the reaction, no? But its density, mass per volume, it doesn't change. Basically, its concentration doesn't change. So that is why we never take solids and liquids. We never take means we don't take it 0. We take it as 1. Because if you take it 0, there is no meaning. No? KSP becomes infinite, which is impossible, right? We just take it as 1. We ignore it. We take it as 1, unity. Okay. So if I write AB2, if I write AB2, what is KSP expression? A plus 2B minus. Okay, what is KSP? KSP is equal to A plus, we write, fine, but B minus whole square, because 2 is a coefficient. So if solubility, if I take S, so if I take this, let me keep it as S, this will be 2S. So what I can write, I just put the values S into 2S whole square. This is 4S cube. S is just a molarity, no? How many moles it is soluble. If it is 1 mole, 1 into S. If it is 2 moles, 2 into S. And use this expression. And for this, no, S into S, this is simply S square. Got it? So similar thing we done here, no? Solubility, our final answer should be C. Okay. So thank you everyone. I think we're done with today's session. So we'll meet in one more beautiful session in the next class. I hope everybody liked, and obviously you have learned so much, so many topics, different topics, no, in today's session. I hope you liked it. Okay. So please give feedback after this class. Okay. Sure. We'll send this PDF in WhatsApp groups. Okay. Thank you everyone. I hope everybody enjoyed it, right? You can contact, no, in WhatsApp group. Okay. Thank you everyone. Please join WhatsApp group. Okay. Thank you. So we're ending the session now. So we'll meet in the next class. Thank you everyone.